Welcome to Electronic Logic, which the code is XTP113, XTP113, or COM112, in which we call Introduction to Digital Electronics. Introduction to Digital Electronics in computer science, while in science tech or other departments we call it what? Electronic Logic. Then now, remember, if we have not subscribed to this channel, endeavor to subscribe. And when you subscribe, remember to tap your notification bell, so that whenever we post the video, you'll be able to receive the message, and you go through the video. Then remember to share this video and also comment. Thank you. If you have not subscribed, but if you have subscribed, no need of subscribing again. Then let's go to topic coding. We said lesson 1. A code is a set of unambiguous rules specifying the manner in which data may be represented in a discrete form. What do you mean by discrete form? A form that doesn't have an approximation. Just like when you go to filling station and they give you fuel using their digital machine or filling machine. You will see the numbers. The numbers are given in 1, 2, 3. While in analog, it will use a pointer, which you begin to approximate. So discrete means 1, 2, 3 values. So we said a code is a set of unambiguous rules specifying the manner in which data may be represented in a discrete form. That's a code. Then we'll come to digital coding. Digital coding is a complete group of combinations of a code which represents numbers, letters, or symbols. This is what we call digital coding. Digital coding is a complete group of combinations of a code which represents numbers or letter or symbols. We now come to use of codes. What do we use code to do? You said number 1, codes are used to represent and process numerical information. We use it to represent data and process numerical information. Code are used to represent and process numerical information. Some information that you don't want to use ordinary number to write. Just like I want to tell you I'm going to come to your house tomorrow. I have to use some numerical numbers, which only you and I can interpret. And that's what we say code. Number 2, codes are used for security reasons, so that others may not be able to read the message, even if it is intercepted. Then what are we saying here? Just like your phone, you use a code to lock your phone. Nobody can be able to have access to your message or whatever that is secret for you, because even though somebody intercepts your phone, maybe pick your phone, you can't be able to go through that message because you use a code to lock that message. Only you that can interpret the code. That's one of the reasons we use code. We say codes are used for security reasons, so that others may not be able to read the message, even if it is intercepted. Then number 3, code converting information into a form suitable for communication or encryption. We said converting information into a form suitable for communication or encryption. What do we mean by encryption? Some of you, somebody may send money from abroad to you, and that person will send a code to the bank, which only you and the bank which the code send will interpret. So when you go there to collect the money, the bank will ask you to interpret the code. If you can't be able to interpret the code, the money will not be given to you. That's what we call encryption. This code was encrypted in the what? In the money given to you. So that it's only when you interpret the code, you will be able to what? Get laid of the money. Then we'll come to what? 4. Number 4. Convert plain text to what? Meaningless combinations of letters or numbers, and the word vice versa. Convert plain text to meaningless combinations of letters or numbers, and vice versa. What does this mean? When I was in school, we normally use shorthand to communicate to us. When I use shorthand to write something here, it's the only person that knows shorthand can be able to what? Interpret what I have already what? Passed to what the message I have passed. But if you don't understand shorthand, this message will remain with you and you will not know what the message is all about. That's what you mean. I was converting a plain text. Just like when I want to take somebody, I'm coming tomorrow, I will say, I will come what? Tomorrow on Monday. I will come what? Tomorrow on Monday. That's on Monday, guys. We put one N here. And that's what? The shorthand. This now can be only interpreted by someone that knows what? Shorthand. And this stand for what? Monday. And the word come, this M, which put dot here, become come. Why this one become I will? I can say that. So now, this only interpreted by someone that knows this particular word shorthand. So when I say converting, I will come on Monday. I've converted it to plain text with a meaningless combination of what? Letters and number, and vice versa. We come to types of code, which we are going to deal in a full detail. We say types of codes. Type of code. We say we have numerous type of codes. To mention but few. We have numerous what? Types of code. To mention is what? But what? Few. We say number 1, binary code, which we call base 2. Number 2, binary coded decimal, which we call what? BCD code. We say binary coded decimal. We call it BCD code, or which we call what? 8421 code. We call it also what? 8421 code. This binary coded decimal is called what? 8421 what? Code as well. So that when you see 8421 code, you know that we are talking about BCD what? Code. Number 3, we have what? Hexadecimal code, which we call base what? 16 what? System of what? Coding. We said hexadecimal code is a base 16 what? System of coding. Number 4, we have what? What we call SX3 code. SX3 code. Number 5, we have grade code. Number 6, we have SX3 grade code. And number 4, we have 4 bits code. Remember, these types of code is what we are going to deal extensively as we go on. We begin to take them one after the other. After binary code, we go to what? Binary coded decimal, which was BCD code. After BCD code, we go to what? SS3 code and hexadecimal code. And we deal with them sequentially and how they are converted from one base to what? Another. This is what we're going to deal in next what? Example. Let's go to example. Yeah, that is the topic. We say conversion of decimal code, which is base 10, to what? Binary code, which is base 2. We are converting decimal code, which is base 10, to what? Binary code, which is what? Base 2. Understood now? We are taking from base 10 to what? Base 2. Then we said, question number 1 said, convert 25 base 10 into its binary what? Equivalent. That means you should convert it to binary code. That is equivalent. What will I do? I'm going to divide through by the base I'm sending it to. From base 10, I'm sending it to base 2. Therefore, I'm going to divide whatever they give me in base 10 through by what? 2. I'm going to divide through by what? 2. Then we'll say 2 divide 25. 2 divide 25. Give me 12. Remember what? 1. 12 divided by 2. Then 2 divided 12 will give me what? 0. Remember 6. 2 divided 6 will give me what? 0 as well. Remember what? 3. 2 divided 3 will give me what? 1. Remember 1. 2 divided what? 1 will give me 0. Why? Because two things sharing one thing, it's impossible. They can't be able to get anything. What they will say is to keep it so that when somebody gives us another thing, it will become what? 2. We can be able to divide. Therefore, we can't divide 1 by 2 things. So we said, keeping what? 0, nobody goes with anything. We now keep our remainder, which that 1 will become what? Remainder, which will keep till when we see another money, add to it, or when we see another item, add to it, we'll be able to what? Share. Therefore, we say that what? 2 divided 1 will give me what? Nobody goes with anything, 0. And we keep the what? 1 aside for other one to come. So, the way of taking it, we see the direction of taking it from down to what? Upward. From down to upward. See the arrow. I will take it to 11001. That means my 25 base 10 is equals to 11001 base 2. You see it there? I said my base 25 base 10 is 11001 base 2. Or we can use this method. Or we can use this method by saying 2 divided 25 will give me what? 12 plus 1. This plus means remainder 1. Then 2 divided what? 12 will give me 6 plus 0. That remainder 0. Are you get what I'm saying? Now 2 divided 6 will give me 3 plus what? 0. That remainder what? 0. 2 divided what? 3 will give me 1. Remainder 1, which is what? Plus 1. Then 2 divided 1 will give me 0 plus what? 1. And this plus 3 plus 1 plus 0 plus 0 plus 1 plus 1 are what? Remainder 1, remainder 0. Are you get what I'm saying? So now, this is 17 of this. So that when you see someone using this pattern, you will know that it is 17 of what we are doing over here. So when I said what? 25 base 10 is equals to 11001 base what? 2. 11001 base 2. Then remember that every of our transaction, every day by day transaction are done by what? Base 10. Yes. The transaction you make every day, even in our mathematics, in our physics, in our chemistry, all the calculation we do there, the value we make use there, they are in base what? 10. Or less is being specified. Any number that is written is all in what? In base 10. Or less when they are not in that base 10, we will what? Specify it by telling you the base where it is. Therefore, if I write something like this, if I write 47, this 47 is in base what? 10. I don't need a soothsayer to tell me that this 47 is in base 10. If you write any number without telling me the base, it means that is what? Base 10. If you write any number without telling me the base, automatically that number is in base what? 10. Then let's assume that I have what? 27 plus what? 15, and they say you should add it up. Then what do? You say 7 plus what? 5, give me 12. Then what do? You said, well, will I write 12 here? No, I can't write 12 here. Why? What is my reason that I can't write 12 here? Because I'm adding this in base 10. And anything above 10 cannot be what? Anything above 9 cannot stay here. Anything above 9 cannot stay here. Then what will I do? 12 divided by what? 10. And that will give me what? 1, remainder what? 2. I will write down my remainder. Look at my remainder here, which is what? 2. I will write down my remainder here, which is 2. Carry my quotient, which is 1, over to the other side. And as I carry my quotient and add to here, become 3. But this will give me what? 42. That means 27 plus 15 give me 42 base what? 10. Why did I do that? Because I'm adding this in base 10. And this is the reason. So when you are teaching a child, you say this plus this give you what? 12. You write what? 2, carry 1. Why do you write 2 and carry 1? Because you are adding this in base what? 10. Therefore, 10 have to what? Divide it to give me a quotient of 1. Remainder 2, which I'm going to write my what? Remainder here, carry my quotient over there. So you will now see that what we are doing, our day-by-day transactions are done in base 10. In our multiplication, division, subtraction, all are in base what? 10. They are done in base 10. Can we go to question number 2? Yeah, we are still in topic conversion of decimal code base 10 to binary code base 2. And the question number 2 said, convert 35.6245 base 10 to its binary equivalent. That's the question there. We say solution. We said here, you remember here, that what? The former one we did was a whole number. The first question, which is question number 1, was a whole number, which is what? 25. But in this case now, we have what here, that's what I say here, we have 2 parts now, which is have what? A whole number part and fractional part. That means, that's what I say here, this 35.625 has a what? 2 parts. Which what? Whole number part is what? 35. And the fractional part is a what? 0.625. That's the fractional part. Then that is, how did I get it? That is, I know that 35.625 is the same thing as 35 after point. I told you anything after point here is a whole number part. So when I say that is what? 35 plus. After I have removed 35, I am listening. After I have removed 35, which is my whole number, what will remain here is 0. When I say 0.625, and that's my word fractional part. Understood? When I say that this have 2 parts, which is whole number part, which is 35, removed, then what will remain here after I remove it is 0. I will have 0.625. Then now, I have my whole number part. I will treat it as a whole number. How did I treat whole number part? I will say that I will divide 2 by what? 2. I will divide 2 by what? 2. When I'm treating whole number part from base 10 to what? Base 2. I will divide what? 2 by what? 2. Look at my whole number part, which is 35. I will say 2 divide 35. That gives me 17, remainder 1. And the 2 divide 17, it will give me 8, remainder 1. And 2 divide 8, it will give me 4, remainder 0. And 2 divide 4 will give me what? 0, 2, remainder 0. And 2 divide 2 will give me 1, remainder 0. And 2 divide 1 will give me 0, remainder 1. I think I have explained to you how we get what? Now 2 divided 1 is 0 because 2 cannot divide 1 thing. So you have to keep it. And keeping it is to keep it as a reminder. And how we say the direction of taking it, you see the direction of taking it. The direction of taking the value, which is down toward upward. I have 100011 base what? 2. And I say 35 base 10 is something at what? 10001 base what? 2. Then I go to fractional part. Coming to fractional part, I have what? 0.625 in my fractional part. In fractional part, I have to multiply through, not dividing through. What I'm going to do in fractional part is what? To multiply through, not dividing through. You see it's 0.625 multiplied by 2. He gave me this. I understand it now. This is where our problem lies. He gave me this. Then what am I interested in? What is my interest here? Whole number part is my interest. I have to take my whole number part, which is 1. I come here. And before I take this whole number part, you remember that this is a what? Dot, which is what? Fraction. I have to put it here. Come over here. I have to put the dot. Have you seen the dot? I put the dot first. After I put the dot, that when I multiply this by this, give me what? 1.25. I am going to take my whole number part. I carry it to what? And write it down here. Are you watching here? I have carried it and write it down here. And when I have taken this one, which is my whole number part, which I'm interested in, what will remain here is 0. That I will write down what? 0.25. After I've taken this one, what will remain here is 0. I will write down what? 0.25. I'll write my 1 down. Then the next thing, I'm going to carry my fractional part as well to multiply it again by what? 2. You now see 0.25 multiplied by 2, and that gives me 0.5. Then what am I interested in? I'm interested on what? My whole number part. And what is my whole number part here is 0, because I told you that after my decimal point, anything here is a whole number part. After my decimal point here, anything here is my whole number part. And what is there? 0. I have to carry my 0 here. Look at here. You see where I write my 0. I carry it and write it down. And after I've taken my 0, what will remain here as well is 0. Then what's this? 0.5. I have to write it down. I have my fractional part that remain after the multiplication. After multiplication, look at my fractional part that remain. I'm going to take it back again. Don't multiply by 2. I'm multiplying by 2. I have what? 1.0. And as I have 1.0, I have to take my whole number part, which I'm interested on. I'm going to carry it over here. Look at what I'm writing it down. Then what will remain when I've taken this 1? I will remain 0. And what I'm going to write down again, which my fractional part will be what? 0.0. That's my fractional part that remain. Then you now see that my fractional part have finished, which is what? 0.0 is nothing. So I'm not going to multiply it again. And that's where it terminates. That one means it terminates here. 0.0 terminated. Therefore, what's the direction of taking? Watch this. Look at the direction of taking. From up down. But the other one was down up. But this time now, what are we doing? From upward down. That means I'm going to take point. That means my 0.625 base 10 is equals to points. Are you following? 1, 0, 1 base 2. How did I take it? Point. 1, 0, 1 base 2. Then I'm going to say therefore, let's see the calculation about it. 35.625 base 10 was rated as well. 35 plus 0.625, which is equals to, where is my 35? Look at it. Look at over here. Look at my 35. 100011 base 2. Look at it. 100011. Are you saying now? What's the next? The next man is this. And who is that man? Point 101. And that's what you see. Point 101 base 2. And I say hence in full, which is our answer now. Become 35.625 base 10 is equals to what? 100011.101 base 2. And that's my what? Answer. And that's all about it. So remember that in a fractional part we multiply by 2, in a whole number part we divide 2 by what? 2. And when you get to 0.0, it terminates. We're no longer to multiply again, and that's where it terminates. Thank you. If you have not subscribed, endeavor to subscribe. But if you have subscribed on this channel, you don't need to subscribe again. And when you are subscribed, if you're new to this channel, and you are subscribed, when you subscribe, you tap your notification bell so that you will be able to to receive all the form. Then, if you have subscribed, remember to follow us from class 1 to the last class. If you jump any of the class, you will not understand the class where you are. So for you to understand this properly, you have to follow us from class 1 to the last class, so that you'll be able to understand it properly. Then, if you want to get this video, you have to go to Easy Learning tutorial class. If you go to your YouTube, type Easy Learning tutorial class, you have to get this video. Then when you have done that, you click on more video, you will see the whole classes in the channel, in the playlist. You study from channel class 1 to the last. Thank you for subscribing. Thank you for sharing this video. Thank you for commenting over this video. That is the question. Topic. We are still in the same topic. Conversion of decimal code, which we call base 10, to binary code, which we call base 2. We said topic, conversion of decimal code, which we call base 10, to binary code, which we call base 2. We said question number 3. Convert 27.8125 to base 10, 27.8125 base 10 to each binary equivalent. They said convert 27.8125 base 10 to each binary equivalent. Solution. We remember that 25.8125 base 10 has 2 parts, the fractional parts and whole number parts. Doing that, I can write this to have a fractional part of 27 and a whole number part of 27, and the 0.8125 base 10 as a fractional part. And what do we do to whole number parts? We not say whole number parts, we not do this. 27, we divide 2 by 2 because I'm converting base 10 to base 2. So I'm going to divide 2 by 2? You get it? I'm converting base 10 to base 2 whole number. I'm converting whole number base 10 to base 2. I will divide 2 by 2. So what am I going to do here? 27 divided by 2 give me 13, remainder 1. 13 divided by 2 give me 6, remainder 1. And 6 divided by 2 give me 3, remainder 0. And the 3 divided by 2 give me 1, remainder 1. And 1 divided by 2 will give me 0. When 2 persons divide one thing, they will not go with anything. Rather, they will keep the 1, so that when the thing gets up to 2, they will be able to divide. So we say 1 divided by 2 will give me 0, remainder 1. Then when I'm taking this, I take it this way. Taking it this way from down to upward, down, upward. I will have what? 11011 base what? 2. That means my 27 base 10 is equals to 11011 base 2. That's it. When I come to fractional part, coming to fractional part, I say fractional part. Then I will use the fractional part with 0.8125 to multiply 2. When I multiply it by 2, so you see that in multiplying it by 2, I will have this. Then having this, when I multiply it by 2, I will have this. Then having this, I have to carry what? The whole number part. What is the whole number part? 1. Look at this. After decimal, if I have this decimal, after this decimal, anything here become whole number part. Are you understanding? Come over here. After this decimal, anything here after the decimal is a whole number part. Then here now after the decimal, what do I see? 1 is a whole number. I carry it over here. Look at where. Then before I carry the 1, I have to put my dots. Why did I put my dots? This decimal is what I've already put here. Then I will carry my what? 1 here and write down the what? The fractional part. What's the fractional part? 0.625. After I have removed this one, what will remain here is 0. It becomes 0.625. After I have removed this one, what will remain here is 0. And then my fractional part becomes 0.625, which remains as my fractional what? Part. Then carry 1 to this place. Then I will use my fractional part again, which is 0.625 to multiply by 2 again. When I multiply it by 2 again, I will have what? 1.25. This 1.25 have a whole number of what? 1. I will take it over here, carry it to this. I will write down the fractional part because when I take this one out, I will remain what? 0.25. Then that's what I write down. I write down 0.25 and carry the whole number part to this, which is 1. Then again, I will use my fractional part again, which is 0.25 multiplied by 2 again. I will have 0.5. This is 0.5. And what is my whole number part here? My whole number part is 0. Look at what is here. After this decimal, what is there? Is 0. I will carry the 0 over here. I will write my fractional part, which is what? 0.5. My fractional part here now is 0.15. After I have taken 0, what will remain is 0.5, which is my fractional part. I will take it back again, which is 0.5 times what? 2. Multiplying my fractional part again with by 2, which is 0.5 times by 2, I will have 1.0. This 1.0, I have to take my whole number part, which is what? 1, over here, where I carry it to right. Then I will write down the what? The fractional part. What is the fractional part? When I take the 1 out here, what will remain here is 0. I have 0.0 as my fractional part, and I carry my 1 over here. And this is where it terminates. You see that my fractional parts have come into 0.0, which is what it has terminated. I cannot multiply again because it has terminated. So what's the next? I will say therefore 0.8125 base 10 is the same thing as what? 0.1101 base 2. 0.8125 base 10 is the same thing as what? Point, which is this point. 1101 base 2. Then I will then say hence 27.8125 base 10, 25 base 10, look at base 10, is equals to, I have come over here, is equals to 11011, look at it here, 11011, which is what? 27, the whole number part, dots. I'm not putting the fractional part. What's the fractional part? 1101 base 2. That's my what? Answer. And look at my answer here. That's my what? Answer.